Okay, we have here to take another integral from the Scranton Integration Bee from 2015, problem 6. You have the integral from 9 to 64, square root of 1 plus square root of x over x dx. Okay, this reminds me of one I did not too long ago, because we also had an embedded square root. I can't remember if that was from MIT or where that was from. But what I said was when we have embedded square root, we almost always want to do a substitution. And I think that's true. I want to do a u substitution. I'm just going to substitute it just for the square root of x right here. And I think this is going to work out pretty good. So we'll do u equal to square root of x over here. I think what I'll do is solve for x here. So just squaring both sides, we get x equals u squared. I'll take a derivative, dx equals 2u du. So we'll go ahead with the substitution. First, we'll update our bounds. It's nice, they gave us perfect squares here, so that's going to simplify nice because we plug it in here into the square root. Like 64, square root of 64 is 8. Square root of 9 is 3. Now it's kind of awkward having the square root around everything. What I'll do is break it up. So like in the numerator, we'll have this square root here, and this is going to become 1 plus u. Then square root of x in the denominator, that's just going to be u right there. And then we have our dx value, that's just going to be 2u du. But then we cancel u's right here. That's nice. And we bring the 2. I'll bring the 2 out front right there. But now we're just about ready to integrate this. What I can do, I'm just going to clean it up so we can see what's going on. But for square root of 1 plus u, I'm going to write it, because we want to use power rule on this now. So I'm going to write it as 1 plus u to the 1/2 du. Now you could do another substitution on this if you want, but you really don't need it because like the derivative of u is just 1 du. So it's not really going to do much for you. We can just do power rule on this and kind of treat this like a variable. So doing that, we'll have our 2 out front. Integrating this, we're going to have 1 plus u. Power rule 3/2, but we need to take the reciprocal of this, so I'll multiply by 2 over 3 here. We just need to evaluate this from 3 to 8. Then we'll do this carefully, multiplying 2 times 2/3. This is going to give me 4/3 in front here. Then we'll plug in, we plug in 8 in here. We're going to have 8 plus 1, 9. So we'll write this, we'll just leave it for now. We'll have 9 to the 3/2. We'll clean that up in a second. And then here we plug a 3 in here. This is going to be 3 plus 1 or 4 to the 3/2. Now, because each of these have like a 1/2 in the exponent, we could kind of do this out, but I think we understand what's happening, that when we have 1/2, we could split this up and write it as like a square root. So we get the square root of 9 here and write this as 3 to the 3. And then here we could take the square root of 4 and we get 2, and then we'll have 2 to the 3. But 3 to the 3 is 27, and 2 to the 3 is going to be 8. 27 minus 8, that's 19. So then multiplying this out, 19 times 4 is 76 over 3 plus c. Just kidding. But then just multiply 19 times 4 and we get 76 over 3 for our solution. Okay, that's it. Thought it was a fun problem from Scranton 2015. Thanks everyone for watching. Have a good day.